My name is Ricardo. I'm jumping in the name of Danielle Diaz and Ulisses Diaz. They're researchers that work directly on the task. They're from Unicamp, university in Brazil. I'm from Unifesp, another university. Here the work explains a little bit of the task, so I'm just gonna jump over it. Here are the examples of one example at least of the 16 classes available on the dataset. The task organizers provided some global features that we used for our models to try to reach the results. Also used some options of convolutional neural networks, mainly the famous architectures for ImageNet and other datasets. They used transfer learning mechanisms where we have a convolutional neural network architecture pre-trained with ImageNet, and these convolutional neural networks extract features from each image, and these features are used in a second model of fully connected dense layers with 512 neurons and an output layer of 16 neurons to output the classes. And then we used three kinds of models. Models that uses only the global image features provided by the organizers. One that uses only the pre-trained CNN architectures, and another one that mixes both of them, deep architectures, deep features, and global features. The first one, the global features, they used all the features provided and then removed only 19 columns. They concatenated all the features and removed 19 columns because it had repeated values or duplicated values, and for each image, so it will give us 185 vector size with float numbers. Then there is the transfer learning models that use 10 architectures, the most famous ones from since DenseNet, all the sizes, Inception, all versions, MobileNet, ResNet, VGGs, and exception. There's also another the models that concatenate global features, and the features use it the 1,166 global features plus the deep features that were extracted from the architectures. So concatenated them into, for example, for VGG16 that has an output of 512, 1,078 input features for the final model, classification model. For submitting a task, there was a total of 21 models that needed to be selected for the submissions. They were trained on 30 plus images and validated on 1,700 and tested on 500 images. And this table shows the results. We can see that the DenseNet on accuracy achieved the best value with no global features, so it's only using the deep features pre-trained on ImageNet, 92%. And you can see, like, using the global features, it reaches a higher value, not so higher, but really close. Then ResNet also has an important result on F1 score, and MobileNet is pretty fast on the results, so it should allow to have a faster. It's important also for the task to have a faster model to predict. Decided to disregard models that used the global features because the results were not much better. The improvement was very small. DenseNet with 201 layers and ResNet were selected for having the best accuracy and F1 score. Mobile because it was fast, and its result was close to theirs. And the DenseNet was the last model selected because it was somewhere in between the best accuracy model and the fastest model. It's DenseNet 121 is 121 layers, so its time is a little bit faster, and its result is quite close to the best result. And the next table shows the final results for the submissions on the test set, on our test set. The mobile net is somewhat worse, has a good trade-off with time and results, but DenseNet 201 was a top accuracy and F1 score, but it's difficult to differ from them, as the time is twice as lower. Somewhat, the results can be improved if the confusion matrix. We'll show you the next slide, because some classes, like the out of patient, is particularly problematic because it only has 4 instances. Maybe to work some data augmentation with it could enhance the results. Another class that is might need some insights are esophagitis, that 107 instance made a lot of confusion, classified as the other class as normal Z-line. That accounts for 30% of the cases of esophagitis were classified incorrectly. And also there was maybe for future work to try to ensemble some models and achieve better results. And this is the final confusion matrix, where we can see the class 16 with instruments. It has a lot of confusion, and it's the main one of the main parts of maybe doing automatic logging for the operation, maybe, and also the out of patient, that it misclassified all instances. And that's a really fast presentation. I might be able to answer some questions, but if not, Ulisses and Danielle, they provided their email, the working notes, and they will be glad to receive your questions and insights.